Welcome back to another Craig and Dave Unscripted. So, if you've been following us for the last 4 weeks, we've indulged a little bit and we've been going through the Craig and Dave Cryptic Challenge. And we had the first winners from Calderstone School on last week, but we're done with that now. So, today, as promised at the end of last week's video, we're going to return to our Ministry of Silly Algorithms and announce our next two winners. Right, Dave. This one, the Cryptic Challenge was very much my baby. The Ministry is something born out of your mind. For those who don't know, or since for the first time, tell everyone, what is the Ministry of Silly Algorithms?
Yeah, the Ministry of Silly Algorithms came about as I was doing my research for our second edition of our Essential Algorithms and Data Structures book, which should be available in January. And I was researching the background to a lot of the sorting algorithms. And as part of that, I came across the BOGO sort and the BOZO sort, which are completely ridiculous algorithms. You would never use them, in a real setting. But I thought they were really, really interesting. And it caused me to think a little bit about some of the exam questions that you get sometimes, and they give you little algorithms and they ask you to trace the code, what's the output, add an extra line of code in, that kind of thing. And invariably, these little algorithms are completely pointless. It's like that they don't really serve any legitimate purpose. And sometimes they put a little scenario around them just to kind of give the a little bit of flavor to the algorithm. But to be perfectly honest, they're completely useless and nonsense. And I just thought, wouldn't it be great as a little bit of a nod to the sorting algorithms that we have to teach, and a little bit of a nod to the exam board questions that we have to answer that are complete nonsense, just to kind of combine that and challenge the community and have a little bit of fun to come up with their own silly algorithms, the kind of thing that syntactically it's correct, it's going to work, it's going to run, it does actually do something. But what it does is really completely pointless. And if it's not completely pointless, it could be done in a much better way. And this is just about creating something that is a little bit silly. So it's one of those things that we like to do with our students just to inspire a little bit more interest in the subject. The Cryptic Challenge was one thing that Craig talked about, doing little logical thinking puzzles and little games like that in class. And having fun with algorithms is something that particularly interests me as well. So that's what the Ministry of Silly Algorithms is. It's just a bit of light-hearted fun and just a bit of a nod to the silly side of our subject.
Yeah, and if you're interested in just learning a bit more about it, what are the rules? How do I submit an algorithm? I've just looked it up while Dave was talking. It's episode 6. So if you look at our Unscripted series, they're all numbered and in order. It was actually very early on. This is episode 36. So if you scroll back in the playlist and look at episode 6, we launched the Ministry of Silly Algorithms. We tell you what the rules are, how to submit your algorithm, and then there's a couple of videos in the series between there and now where we've been releasing winners. Right, so everyone wants to know, what do you win? So if we pick your Ministry of Silly Algorithm and choose to feature it on one of our unscripted videos, which we do on our sort of ad hoc basis, you become a proud owner of one of these official member of the Ministry of Silly Algorithm mugs. And I will point out, as I do every time, Dave, you cannot obtain this mug on the Craig and Dave shop. It is not a piece of merchandise you can buy. You can only win one of these mugs by submitting to us your working silly algorithm. And then if we feature it on a video, we send you a mug. So, exclusive merch. Right. If I move on, so we mentioned we've had previous winners. Kirsty Clark and Nick there. I think they were our first 2 winners. We announced those in the week 10. We returned and then added Charlie, had an excellent little silly algorithm called Spelling. How many winners have you picked out today, Dave? How many are we awarding with a mug?
Yeah, so I've picked out 2 further winners for today, and it's worth
Brilliant.
just saying for those of you that have submitted algorithms to us, we do have quite a few, and it doesn't mean that you aren't going to become a member just because you haven't had a reply from us, other than the courtesy reply to say thank you for your submission. Just because you haven't had a subsequent follow-up email to say welcome to the Ministry of Silly Algorithms doesn't mean that you won't eventually join us. In fact, one of the algorithms we're going to have a look at today was actually submitted to us all the way back last May, so actually quite some time ago. But as Craig says, we do this on a sort of very ad hoc basis, and we'll pick out algorithms from time to time. So don't be put off. If you'd like to get involved, it doesn't mean that you will necessarily have to wait a year. You know, if your algorithm really sort of impresses and interests me, then the chances are it might appear a little bit sooner. So you know, if you've submitted an algorithm to us, the chances are that at some point you will join our Ministry of Silly Algorithms. But we're just going to do these videos on an ad hoc basis and sort of pick random algorithms out that we like the look of to feature on the show. So there we go.
Brilliant. Well, let's look at the first winner. So the first one then, Alfie Giffen. I was going to say Griffin there. So Alfie Giffen, biggest.py. And the beauty of these is Dave is exclusively in charge of picking the silly algorithms that will get awarded the mug, which means I have no idea what I'm about to see, which is quite nice. Right. Okay. Show us then Alfie's Python program, biggest.py, and why did you feel this was worthy of a win in the Ministry of Silly Algorithms?
Yeah, absolutely. So I did look at this program the first time that Alfie submitted it months ago. And I thought, oh, that's interesting. I like the look of this one. And I haven't looked at it, admittedly, for months since I looked at it for the first time. And when I opened this up, I couldn't remember really what it was doing. I just kind of opened it up and ran it and had a look at the output. And I thought, I can't even remember what this is and what it does. And of course, to be a member of Silly Algorithms, it's got to be a little bit silly, a little bit obfuscated, so you can't tell immediately what it is that this thing is supposed to do. And of course, we encourage all of the naughty practices in programming. So we definitely don't want any comments that would help me understand this algorithm. No. We don't want sensible identifiers. No. That's variable names. Structured programming, certainly not. In fact, anything that is likely to turn this into a sensible and decent, well-maintained algorithm, that's never going to win a place in the Ministry of Silly Algorithms. So I've only got myself to blame. I look at the algorithm and I haven't got a clue what it's doing.
Well, I mean, anyway. Sorry, Dave, just quick. I know you're going to go through it. Just while you were talking, I'm going, okay, we've got a couple of lists there. A's got some values and B's just got naught in it. And then immediately I shove the values from one into another. B1 equals A1. And I'm not even doing it. I'm not even going B0, then B1, then B2. For some reason, I'm going B1, then 0, then 2. Why not? And then 3 random variables, Z1, 2, and 3 equal false. Excellent. Oh,
yeah. Well,
yeah. I'm like, brilliant. This, no wonder you've picked this one out. Still not got a clue what it does, but go on.
I know this is an absolute belter, this one, actually. If you have a look at it, right, I reckon I could write a very similar program within a couple of lines of code. All right, but you know, why only have 2 lines of code if you can have 20? You know, for the Ministry of Silly Algorithms, it's just the way it is. Anyway, yeah. Any idea what this program might do then, Craig?
Right. So I got down to the just scroll up a little bit. Okay, so I've got down O while O is not equal to no, O equals this. Okay, right, scroll down. So then we're comparing these false values. This bottom bit will probably give it away. Is all that? No. Okay, very quickly. Is all this program telling you which of the items in the first list is the biggest? Is that all it's doing?
Yeah.
Wow, which you're right.
It's a
You're probably right.
perfect contender for the Ministry of Silly Algorithms.
This is one of the things that Dave mentioned. To be a contender for the ministry, it must be a working algorithm. We must have to get this, run it, and it does something without errors.
Yeah, absolutely.
So this program looks at that first line of code, line 1, a list with 126 and 12, and it tells me which of those is biggest. That's what it does. Excellent.
Yeah, that's
Brilliant.
exactly what it does. And this is the kind of nonsense that you have to trace when you're in exams to kind of prove that you can trace algorithms. Oh, it's an absolute belter. Let's make the output window a little bit bigger. Let's give it a run and see what the output is. Okay, so we've got 120, 60, and 12 as our input numbers. And when Alfie first gave me this program, he had very large numbers in that list, and I ran it, and it kind of looked like it was going to loop forever. It wasn't, but he did advise me to use smaller numbers than the one that he'd presented originally. So I've done that just to make it a little bit quicker. Let's give it a run and see what happens. There you go. Look, 120 is the biggest.
Well, he's not wrong.
No, it's not wrong. Like we said, the program has to work. It has to be functional. It has to do something. It just isn't going to be doing it in the most efficient way. So let's just have a little look at this output, because we'll work out how it is concluding that 120 is the biggest number. Okay, so we scroll all the way up to the top. All right, so our numbers were 120, 60, and 12 to start with. And then they became 59, 119, and 11. So it subtracted 1 off the numbers, okay? And then in the next iteration, they became 58, 118, and 10, okay? And so it gradually reduced by 1 in each iteration the value of the number, okay? And I guess whichever one sort of got to 0 last must be the biggest one.
Well, it's a perfectly valid way of finding the biggest number from a list. It works. It's done it. Is it efficient? No. Are the variable names badly written? Yes. Is it a completely pointless and convoluted piece of code something written to? Yes. Can I see why you picked it as a winner? Absolutely.
Pointless. I mean, if you've got a list of numbers and you want to know, which number in this list is going to be the biggest, then that can be useful, but not written like this.
Yeah, absolutely. Oh, that's brilliant. Well, that was Alfie, did you say? Yeah. Well, I am with you here. What a valued winner. Very worthy. That was the word I was after. A worthy winner. Oh dear. Right. Was there anything else particularly you wanted to pull out from that one, or shall I move on to the second person?
We could go through it and how it's working, but essentially we just got to uncover together there by looking at the output exactly what's going on here. Yeah, brilliant. Lovely, Alfie. If I've got 3 numbers and I want to know which of the 3 is the biggest, then why wouldn't I just subtract 1 from every single number until eventually the largest one becomes 0? Of course.
Yeah. Very, very inefficient. Brilliant. Love it. Okay, cool. So that was you picked 2 this time. So well done, Alfie. Right. Who else did you pick? Let's have a look. Oliver Martin. Okay. Odd ski, even ski. Oh, I see what you've done here. .py. Tut, Dave, you've missed that.
Oh, yeah. We'll
I'll let you off. I'll let you off. Right. So I'm guessing this is going to be some ASCII-based program. Odd ski, even ski. Fantastic. Right. Show me this one and why you felt this was worthy of entry into our ministry.
This is another belter.
You have so much fun with this, don't you?
I love it. I absolutely love it. I mean, I love computer science as it is. And, I spend most of my time trying to think of the best way of doing things, whether that's the
Sure.
best way of teaching, whether it's the best algorithm that I can write to solve a particular problem. And so I spend most of my life looking for the best solutions. You know, that's what computer scientists do. So this is an opportunity to just do the opposite, you know, and I get a lot of joy from that, actually. So, yes, this is welcome to odd ski, even ski. The clue is in the title. Craig, what could this program possibly do?
I mean, there's a lot of stuff there. I am guessing you're going to enter a number, and all of that code is just going to basically tell me whether it's odd or even.
That's exactly right.
There's an else statement down there. It's neither ski. Does that mean I can enter something that's not an... Oh, go on, give it a go. I want to see how this works.
I'm not actually sure. I mean, I haven't robustly tested this. I did test it with a range of values and negative values and 0 and things like that, just to see what it did. I've not been able to get it to output it's neither ski. So I don't know whether that's just a sort of belt and braces on the end, because, you know, when you do conditions like that, you should always make sure that all paths, you know, succeed as part of testing. And so it's not uncommon to have an else at the end that's a bit of a catch-all, really. You know, if this fails in all sorts of ways, then, you know, do this instead. And if that's what's happened here, Oliver, then tut, because we would not approve in the Ministry of Silly Algorithms of having a catch-all at the end. It would be far better if it behaved unpredictably. But to be fair, the rules also state that the algorithm has to run and it has to be error-free. So yeah, if we've done it for those purposes, then that's absolutely fine. But yeah, it essentially tells you whether a number is odd or even. And I believe I could probably do this in 2 lines of code. One would be a simple if statement, and the other would just be outputting, you know, if it's odd or even. And to be fair, you know, 2 lines of code, yeah, if you only wanted one of the things output, if you wanted to say, you know, it's odd or it's even, I could do it in 2 lines of code. But if you then need to say else, then we are going to extend that to 4 lines. But I certainly don't need 26 lines, which is what we have here. Okay, some of them are blank, to be fair, but yeah. Well, how does it work? That's the question. Let's give it a run, actually, and see what happens, and then we'll try and unpick it a little bit. Okay, let's give him a run. Okay, enter a number. So let's go for the number 5. It's odd ski. Yay!
Hey.
Right, let's give it another run. Let's try 6. It's even ski.
And what happens, by the way, if I put in a character or an @ symbol? Does it crash?
Yeah. Okay, let's give that a go then. So let's put in an H. It's neither ski. There you go. Oh, it doesn't crash. It copes with anything, which is brilliant. Actually.
I like that.
Let's give it another number. So, like 78, or let's push the boat out. Let's go 787. Ooh. It's odd ski. There you go. It did it pretty quickly as well, didn't it? If we contrast that to the biggest algorithm we were looking at a moment ago, this executes pretty speedily. So you would think at face value that actually it's not a bad algorithm, right? It executes pretty quickly. It gives us the correct answers. But until you look at the source code, right? Any ideas what's going on here?
Length n equals n lesser. What's that first bit even doing? Length n equals... Okay, so I work out the length of the thing you've entered. Why do I care about that?
Yeah, it's an absolute classic, isn't it?
Lesser length n is whatever the other one was, -1. Brilliant. Okay.
I know we're in danger of almost having sensible variable names there, but I don't know about that. That's very good.
And then what's going on here? 0 ski is odd 0, 1 ski is odd 1, and max ski is odd colon. So I don't know what's happening at all there, Dave.
Okay. Well, odd is the keyword in Pascal that takes a character and it returns its ASCII value. Okay, so if you've got the letter A, capital A, for example, it would return 65 as the ASCII value. So what you're doing is Zero-ski is getting the ASCII value of the alphanumeric 0. That's what's happening there. And we've got a couple of empty lists. Okay, and then
when
we've
Dave
got
said
a
Pascal,
couple
by
of
the way, he meant Python.
So, any idea?
For even in right, I see. Okay, so now I've got the numerical values of the ASCII characters, and so MAXCI or colon, I'm guessing, I don't remember my ASCII tables off my head. I'm guessing that is at the end of all the alphanumeric characters. It's the maximum value they could have from something you would type on the keyboard, ignoring escape characters and all the rest of it. So if it's in the range from the lowest to the maximum to, okay, I see. And then, so that's the bit that's actually determining even ski dot append even. Dot append even. I've lost where even is. What on earth's even?
Yeah, so what it's doing is it's getting the ASCII value of 0.
Yeah.
And then it's getting, the ASCII value of 2 and 4 and 6 and 8, etc. Okay, and putting those ASCII values into this list called Even-ski. Okay, so you've got the ASCII values of all the even numbers, basically, and then you've got the ASCII values of all the odd numbers in Odd-ski. And this bit of code up here, like you said, it's kind of extracting the last digit off the number that you entered, because obviously if a number is odd or even, the only thing you're interested in is the digit on the right, the least significant digit, because if it's odd, then it's not divisible by 2, and if it is, then it is, but this isn't working quite like that. What this is doing is it's taking the last digit of the number that you entered and it's converting it into its ASCII value here. Okay, and then it's using a condition to check whether the ASCII value of that last digit of the number is in the list. If it's in the Odd-ski list, then the number is Odd-ski. And if it's in the even list, then it's Even-ski. And if it's neither, because it was a character, as you just showed by testing, then it's neither-ski. So it's calculating whether a number is odd or even by converting it to an ASCII value, and then seeing if that value is in a list
which you've had to create and append items to.
Yeah, it's utter nonsense, which makes it a perfect entry for the Ministry of Silly Algorithms. I mean, for a start, if you did want to take this approach, there's no need to convert them into the ASCII value at all. You could just append the characters into the list and see if the character is in the list and take that approach. But no. We had to add an extra layer in there that was completely unnecessary, just to, confuse students. And then on top of that, it's just, that's not how you determine if a number is odd or even. You would use modulus, and if you modulus by 2, if you get a 0, then it's an even number, and if you don't, it's an odd number, and that's how you do that algorithm. But my approach is definitely not the way forwards for the Ministry of Silly Algorithms. I can only hand it to Oliver, who clearly has a far better algorithm for achieving the same objective. So well done, Oliver.
Absolute genius, Oliver. Well done. And Alfie, too. I'm glad you've shown those to me. 2 very deserving members of our Ministry of Silly Algorithms. What's that now? 1, 2, 3, 5 people in our ministry. But as Dave said at the start, if you've submitted an algorithm, it doesn't mean we won't choose it in the future videos. We do these fairly sporadically, and we have had some brilliant entries. If you're learning about it for the first time, you want to give it a go, fantastic. Just a very quick recap. So video 6 will tell you fully, but as a quick recap off the top of my head, as we've said, it must be an algorithm that compiles and works. One thing we haven't mentioned is it must be written in Python. We're just keeping it. That's the only language we're accepting. So you literally send us the .py file. It must work, it must compile, and it must do something. Pretty much they are the rules. We do have a few more details in video 6 if you want to watch it. We don't want algorithms which are pages and pages and pages. I mean, have we said, do we want them to be convoluted and obfuscated? Why do something in 2 lines when you can do it in 20? Yes, but don't send us something that's 1,000 lines long, because we won't have time to talk through it on a video. But within that, have some fun with it. Yeah, get them in. Listen to all that good programming practice your teacher's been drilling into you. Throw it all out the window and write us an algorithm. That's it, isn't it, Dave?
Yeah, it is absolutely, and it's another one of those examples of just silly teaching techniques. If you when students go into exams, if they get a sensible question, which is, how can a programmer make their code maintainable? It would be written in a better way than I've just described, but in essence, the question might be, how does a programmer make code maintainable? There's some things to revise, there's some things to learn, there's some basics, including comments, including white space, including sensible identifiers, including subroutines. And so by having a bit of fun with this and reversing it and doing the opposite of all those things, it becomes memorable. And so students, when they're in exams and they get a question that otherwise would have been just a bit of dry revision, they've got an experience to call on, and they can think, oh yeah, I remember when we had those couple of lessons and we did some silly algorithms, and what did we have to do for that? And for some reason, it's more memorable when you do that. Yeah. And it's like, oh yeah, I remember it was really silly because it didn't have good variable names and nobody could understand what was going on, and didn't structure it very well. And so, just reverse those comments and that becomes the correct answer to the question you're being asked in exams. So I think good teaching is about creating memorable learning experiences as well. So it might on the surface feel like this is complete nonsense. Why are Craig and Dave, advocating these practices that we don't want to see? Because it's memorable, and students will be able to recall the opposite of that and answer exam questions better than they might otherwise have done. So Craig and I are always looking for those opportunities to have a bit of a laugh at ourselves and our subject. And at the same time, if there's a little bit of added value in there that can help students be successful in exams, then more the better. So there we go.
Brilliant. Well, Alfie and Oliver, well done the pair of you, deserving members of the Ministry of Silly Algorithm. By the time this video goes out, we would have reached out to you to ask you whether you'd like to receive one of the exclusive ministry mugs. So hopefully you've checked your emails and they'll probably be with you by now. Get your submissions in if it's the first time you're hearing it. But I think that's it for us today. A slightly shorter one than usual. So thank you very much, everyone. And we'll see you again next week for another Craig and Dave Unscripted. Cheers. Bye-bye.